What is going on, everybody, and welcome to part 17 of our machine learning tutorial series. We've been working on k-nearest neighbors, and let's get into it. Don't want to waste any more time here. So we've started creating this k-nearest neighbors function. All we've done so far, though, is just warn the user when they're trying to do something stupid. So now we actually need to create the k-nearest neighbors part, calculate who are the k-nearest neighbors, what are their class, what is the class of whatever we're predicting based on the comparison to the data. Okay, so what we need to do, how could we do this? How can we compare a data point to the other data points to find out who is the closest data point? And therein lies the problem with k-nearest neighbors. To do this, we have to compare the prediction point to all other points in the data set. That's the problem with k-nearest neighbors. Now, there are actually some additional things we can do. You can do what's called a radius. So you can look within a certain radius of a point, and then you can kind of like forget the outliers. And that can save you a little bit on the calculation of like Euclidean distance. You can find out much easier is a point inside or outside a radius than you can to calculate the Euclidean distance. Okay. So anyways, we're not going to get into that, but just keep in mind that this is the problem with k-nearest neighbors. So what we're going to do is we're just going to grab basically a list of lists of the distances. So what we're going to say is, you might say something like this. Like you might say distances equals a list. And then you're going to say for group in data. And so that would be like for each, keep in mind, data is whatever you pass through here, but in this case, it would be this data set. So for each group, so for each class, basically. So for a group in data, for features in group, or rather features in data group, data group. So this was now iterating through the features here. What do we want to do? Well, we need to calculate Euclidean distance. Right? And I got rid of the Euclidean distance. So in order to save y'all time, I'm not going to write it out. I'm just going to copy and paste here because we're not going to actually use this version. But going with the version that I wrote previously, we would say that, right? Square root of feature 0 minus predict 0 squared plus features 1 minus predict 1 squared. And then take the whole square root of that, right? That is the equivalent of what we wrote earlier. Unfortunately, that's the algorithm, but it's not fast. It's not a very fast calculation. So, I mean, on our data set, it would be lightning fast. And probably on the breast cancer set, it would be pretty fast. But in this case, no. So we definitely want to change it. So what we're going to change it to is, for example, this would be a faster version. Also, the other problem here is, what if you have... This works with 2 dimensions, but if you had 3 dimensions, right? This will not change. This is hard-coded to only do k-nearest neighbors on two feature dimensions. Bummer, all right? There are a few things that we could do to counteract this, specifically with like a for loop would do it, like a one-line for loop could figure it out. But to counteract for a dynamic number of features, you could do something like this. So first of all, we're using a NumPy square root. We're using NumPy's version of sum, and then we're also using NumPy arrays where we can actually just subtract NumPy arrays, square those NumPy arrays, and perfect. We get the same value for Euclidean distance here as well. But we're going to go ahead and not use that one either because it turns out that NumPy even has a more simple version, and that would be the following. I guess this one I'll write out because this is the one you're going to need to write out. So it's Euclidean distance equals np.linalg, or it's basically linear algebra, linalg, right? .norm. Okay, it's just another name basically for what we're going to do here, which is Euclidean distance. So this is the norm of np.array, and we're going to say features, right? This is features corresponding with features minus minus np.array predict. Okay, and this obviously no longer does it look like the Euclidean distance formula, and that's why I did not want to use this initially, because this is you're kind of cheating using this, like this is much higher level. So anyways, but we're going to use it because it's faster, but I did want to show you the true way to write it if you needed to. Okay, so we've done that. And now what we're going to say is, let's do, whoops, I hit my mouse. Let's do over here. So we've got, oh, actually what we need to do is now we need to do distances.append. And we're going to append the following. We're going to append a list. So we're going to say whatever the Euclidean distance happens to be, and then we're going to append the group. So it's the distance, it's the distances, and then a group. So it's going to be a list of lists where the first item in the list is the actual distance, the second one's the group. This way we can sort that list, take the 3 things in that list, and then get the firstth element, and those are the groups. That's my thinking. So now we're going to come down here, and we're going to say the votes equals, so I guess let me explain how I'm going to do this first. So again, I'm going to use a one-liner for loop, but I'll write this one out and then I'll explain it. So basically, it is going to be the votes is equal to I1. So again, I1 is the group. Once we know what the top 3 distances are, we don't actually care what the distance is. We just care about it because we want to be able to rank the distances. After we've done that and gotten the top 3 or the best closest distances, we don't care what the distance was. So I1 for I in sorted distances to k, right? Because after we've sorted the distances, we only care about the distances to k. So it would almost be the votes are equal to, for distance I1. But this just allows us to populate votes as a list that is just simply the groups, right? Or the categories, labels, whatever you want to call it, class. So there you have votes. And then we're going to say the vote result is equal to counter of the votes dot most underscore common. And how many of the most common do we care about? We just care about the first one, the one that is the most common. And then we're going to take 0, 0. So most common, it gives you like first of all, it comes as like an array of a list. So you take 0 first and you get the list. And then you take the 0th again because that list tells you what the most common, how many there were, or the most common group, and then how many there were. So there's 2 things in it. I think it's actually a tuple of an array. I can't remember. Anyway, it's like that. So we're going to take those. So, and in fact, I mean, we could print, just so you can see, countervotes.mostCommon, just so you can not take my word for it. Okay. So then you've got vote result, we return vote results, and we've done k nearest neighbors. So now, let's say we actually want to run this darn thing, and we're going to say results equals, and let's just copy this. Copy, paste. We're going to pass through dataset. We want to predict on the new features, and we're going to say k equals 3, no problem. Okay, and now let me print results. So we'll also get this other print out, but that'll be okay. And then we'll maybe get an error even if we're lucky. Nope, no error. Cool. So it's actually a list of a tuple. Okay, good thing I printed it out because I guess I was making it up. So what we get here is that the return is that it's the most the most voted thing was R. It turns out k equals 3, so all 3 were R, and of course the vote result is R. So we get that the class back of this data point right here is an R type, which, as we already saw, like we kind of expected that to be the case. So good. So now there's a couple of things that we want to do. First of all, we might want to compare it to scikit-learn's version. The other thing we could do, I mean, like we could print, or like we could graph this just for example. So let me do, we could take this, copy, come down here, paste, and I'll take this away. And new features. So instead, well, yeah, we can plot that, and then is it color? Yeah, color equals results. I think we'll get away with that. So if we do that, Right. We just need to change the size, but that was the new point, right? And so indeed, it classified it in the correct group. So now what we want to do is we want to compare that to scikit-learn's version of k nearest neighbors. Okay, so we're gonna use this k nearest neighbors algorithm against that breast cancer data, and we're gonna see how well we compare to scikit-learn. So that's what we're gonna be doing in the next tutorial. So if you have any questions, comments, concerns, or whatever, leave them below. Otherwise, as always, thanks for watching. Thanks for all the support and the subscriptions, and until next time.